Hi guys, my name is Jesseline and this is a video about squares. We're going to talk about the properties of squares, the definition of a square, things that you can use in proofs that you have to do in geometry. Because you have to know the theorems, you have to know the definitions, you have to know the properties because you use all of these in these theorems. So by definition, a square is a quadrilateral with 4 congruent angles and 4 congruent sides. So all sides are congruent and all angles are congruent, okay? So that is a square by definition. 4 congruent angles, 4 congruent sides, okay? So a square has all the properties of a parallelogram and a rhombus. If you haven't watched parallelogram video or the rhombus video, please go and watch that first, okay? Because all those properties apply to squares too. Let's review those properties. Those properties say opposite sides are parallel. So opposite sides are parallel. Opposite sides are congruent. Opposite sides are congruent. And opposite angles are congruent. And consecutive angles are supplementary, means they add up to 180. And diagonals bisect each other. So if we draw the diagonals here, they bisect each other. Let me erase that. There we go. They bisect each other. Which means that they do for this is congruent to this, and then this is congruent to that, okay, when they bisect each other. So what a square adds on to this, the properties of a square that adds on to the parallelogram and rhombus properties, is 4 right angles. So I'm going to draw another square. These are the properties that are added on to the parallelograms and the rhombus. So this is what distinguishes it from being a rhombus or a parallelogram. Now a square is a parallelogram and a rhombus, but a square is a more specific name for it. So it has 4 right angles, 4 congruent sides, not just opposite sides are congruent, 4 congruent sides. Diagonals are congruent. So the diagonals are congruent. And the diagonals are perpendicular, which means that they all create a right angle right there. And diagonals bisect opposite angles. When it says bisect opposite angles, it means that it splits that angle into 2 equal angles because it bisects it, okay? A rectangle doesn't do that, but a square does. A square's diagonals bisect the opposite angles. So those 5 properties are added on to the properties of the parallelogram and rhombus, and which make those 5 properties make it a square and not just a parallelogram or not just a rhombus. Okay, so square examples. So those are your properties that you can use in a proof. If you're having to prove something like that it's a square, well, if you can prove that all 4 angles are right, then you are in a step towards proving that it's square. You can't say that yet because you could do it by definition. If all 4 angles are right, that's a property of a square, then you can state, well, all 4 angles are congruent, which is half of the definition of a square. The definition of a square is all 4 angles are congruent and all 4 sides are congruent. So once you establish that, then you can state that it is a square. So let's talk about, but you use the properties to get there. So let's talk about the properties and how we can write this. So I'm stating that this is a square, okay? So I'm telling you already that it's a square. A, B, C, D. Okay, so I'm telling you already that this is a square. So if I tell you AB is 10, and I want you to find AD, and I also want you to find DC. So I'm telling you AB is 10. So this side right here is 10. So AB is 10, and I want to know AD and DC. Well, knowing the properties of a square means all four sides are congruent, which means that AD would also be 10, and so would DC, because all four sides are congruent, using the property of a square. So now if it says CE is 5, what is DE? Well, CE, so the diagonal C all the way to the middle, E, is 5. DE would also be 5, because properties of a square say they bisect each other, and diagonals are congruent. But knowing that they diagonals are congruent, and if they bisect each other, and if they're congruent, which means all four of these are congruent, since they bisect each other and diagonals are congruent. Okay, so DE would have to be 5. And then the measure of angle ABC is what? So ABC, so the measure of this angle right here, we know is 90 degrees, because by definition of a square, not by definition, property of a square says all angles are right. So the property says all angles are right, so that's 90. Let's do the measure of ACD. So ACD. So ACD is this little angle right here. We know one of the properties of a square is that the diagonals bisect the angles. If we know the angles are all 90 degrees, and if it bisects it, means it splits it into two congruent angles. So 90 divided by 2 is 45. So 45 degrees. So make sure and go over those properties again and those definition of a square, and use those in your proofs that you're doing in your class. Thank you for watching.